Chapter 3, Protocols of the Internet. Who decides how computers talk on the Internet? The networking protocols are created by groups of people. It's a work in progress. In the past, every computer spoke in its own way, but on the Internet, computers use the same set of rules for talking to each other. This is called a protocol toolbox. When computers send data to each other, it is broken down into tens of thousands of small packets and sent across the Internet. TCP/IP protocol is a set of rules each computer uses to talk to each other and send data back and forth. Every device on the internet, also your computer and phone, has a unique IP address, which is made up of numbers. Computers use numeric IP addresses, but for people, it's easier to remember addresses that consist of words. These addresses are called URL addresses. DNS servers keep lists of all addresses, and they can convert URL addresses to IP addresses. Exercise 14, digital data. What does information look like? Computers can only process information that is in digital form. This means that all data is first turned into ones and zeros. Instead of sending messages, pictures, or videos over the internet, computers send data consisting of the numbers 1 and 0. A lot can be done with only 2 digits. Take a piece of paper and put it on top of the picture. Color in the squares according to the rules. What did you find? Can you make your own pixel character? Exercise 15. Packet switching and TCP/IP. Secret messages. When you send your friend a message or picture over the internet, the digital information is broken down into smaller chunks called packets. Packets are sent to the recipient through many different routes and then reassembled. Each packet includes information on the sender and the recipient and instructions on how the message fits together. Can you help reassemble the messages from Ruby, Julia, and Django? Pay attention to the sequence so that you get the words in the message in the right order. To Django from Ruby, sequence 3 out of 3, message you. To Ruby from Django, sequence 3 out of 3, message today. To Django from Ruby, sequence 1 of 3, message I. To Ruby from Django, sequence 1 of 3, message let's. To Django from Julia, sequence 2 of 3, message 4. To Ruby from Django, sequence 2 of 3, message play. To Django from Julia, sequence 3 of 3, message food. To Django from Ruby, sequence 2 of 3, message like. To Django from Julia, sequence 1 of 3, message what's. Exercise 16, IP address. Internet's address book. Computers use numeric IP addresses and people use URL addresses that are made up of words. DNS servers all over the world keep lists of IP and URL addresses. Client, wikipedia.org, helloruby.com, youtube.com, google.com. DNS server, I keep records, IP Ozoit, 74.125.224.72, 208.65.153.238, 54.231.80.226, 91.198.174.192, URL, google.com, youtube.com, helloruby.com, wikipedia.org. Servers. Use the DNS server list to figure out the IP address of each website Ruby wants to visit. Can you tell which image is shown on each website? If you run into a page with error message 500 internet server error, it means the server hosting the website is down. A 404 error message means the page can't be found. Exercise 17, URL. Fix the URL. Putting together a URL address is almost like assembling a jigsaw puzzle. Start with the protocol, then add the domain pieces, and complete with a file path if needed. Protocol HTTP:// the domain is www.helloruby.com with www as a subdomain and .com as a top-level domain, and /play is the file path. Can you help Ruby create 4 URL addresses for Hello Ruby with the pieces below? To get everything in the right place, pay attention to the colors and shapes. All URL addresses do not necessarily have pieces in all the different colors. Discuss. Visit some of your favorite websites and write down the URL addresses from the address bar. What elements can you find?